Question 2, Part A. The diagram shows a sketch of the curve y equals 6x squared minus x cubed. The curve cuts the x-axis at L and has a local maximum at M and a point of inflection at N. Part 1. Find the coordinates of L. The point L is an x-intercept, so that's a point where the graph crosses the x-axis. This implies that the y-coordinate of point L is 0. Hence, 6x squared minus x cubed equals 0 at point L. So we need to solve this equation for x. Also note that point L is to the right of the origin, so x must be greater than 0. Now factorising out x squared on the left-hand side of this equation, we get x squared outside of 6 minus x in brackets, and that equals 0. So by the null factor theorem, we have x is equal to 0 or 6. But x must be positive because point L is to the right of the origin, as I stated earlier. Therefore, the coordinates of point L are 6, 0. Part 2. Find the coordinates of M. Point M represents a stationary point. Hence, the value of the first derivative y dash is equal to 0. So differentiating y equals 6x squared minus x cubed with respect to x, we get y dash is equal to 12x minus 3x squared. And we want to solve the equation for x. 12x minus 3x squared is equal to 0. Now note that the value of x must be positive because the location of the stationary point is to the right of the origin. So we can simplify this equation by dividing all terms by 3x. And the equation simplifies to 4 minus x equals 0. And we get x is equal to 4. But we need the y-coordinate of point M. So noting that y is equal to 6x squared minus x cubed and substituting 4 for x into that equation, at x equals 4, y is equal to 6 times 4 to the power of 2 minus 4 to the power of 3, which gives us 32. Therefore, the coordinates of point M are 4, 32. Part 3. Find the coordinates of N. Since N is a point of inflection which is given in the question, the value of the second derivative y double dash is equal to 0. Now from part 2, we found the first derivative, y dash is equal to 12x minus 3x squared. So to get the second derivative, we just have to differentiate the first derivative one more time with respect to x. So differentiating y dash, we get y double dash, or the second derivative, is equal to 12 minus 6x. Next, we solve the equation 12 minus 6x equals 0. And by inspection, we get x is equal to 2. Now at x equals 2, the y-coordinate we find by substituting 2 for x in the original equation. We get y is equal to 6 times 2 to the power of 2 minus 2 to the power of 3, which equals 16. Therefore, the coordinates of point N are 2, 16.